Hey everyone, if you are studying for Cambridge or Edexcel Physics, you know that the series circuits are the bread and butter of your electricity lesson. But here is the thing, examiners love to take simple series circuits and add just enough complexity to trip you up. Today, we are going to break down the core rules and solve a typical exam style problem so you can walk into the paper with total confidence. In this electric circuit, a 100 ohm resistor, a 200 ohm resistor, and a 1.5 volt cell are connected in series. So the question is like this. First part of the question is to find the total resistance. Next, we are going to find the current flowing in the circuit. Next, we are going to find the potential difference across the resistor A. And finally, we are going to find the potential difference across the resistor B. So we shall move to the first part of the question. Here the first question is to find the total resistance. You know that in a series connection, we can find the total resistance by adding all the resistances. So the total resistance is equal to RA, the resistance of A plus resistance of B. So the resistance of A is 100 ohm and the resistance of B is 200 ohm. So the total resistance is 300 ohm. Next, we'll find the total current flowing in the circuit. To find the total current flowing in the circuit, we have to apply the Ohm's law. That means V equals IR. So here the voltage should be the EMF of the cell, that is 1.5 volt. And you have to find the current flowing in the circuit, and the total resistance is 300 ohm. So current is equal to 1.5 divided with 300. 0.005 ampere. And the other thing you want to know is, in a series connection, same current is flowing through each device. That means current flowing through the cell is also 0.005 ampere, and the current flowing through the resistor A is also 0.005 ampere, as well as the current flowing through the resistor B is also 0.005 ampere. Likewise, in a series connection, same current is flowing through each device. Next, we'll find the potential difference across the resistor A. Now you know that the resistance of the resistor A is 100 ohm and the current flowing through the resistor A is 0.005 ampere. So we can apply the Ohm's law individually into the 100 ohm resistor. So then we shall apply Ohm's law there. So the current is 0.005 ampere and the resistance is 100 ohm. So the voltage or the potential difference across A is volt. Finally, we shall find the potential difference across the resistor B. So like in the previous question, we are going to apply the Ohm's law individually into the resistor B. You know that the resistance of the resistor B is 200 ohm and the current flowing through the resistor B is 0.005 ampere. So let's apply Ohm's law there. So the Ohm's law means V equals IR. So the current is 0.005 ampere. The resistance is 200 ohm. So the answer is 1 volt. So the potential difference across the resistor B is 1 volt. Finally, we'll try to figure out some relationships associated with these series circuits. Previously, we have calculated that the potential difference across the resistor A is 0.5 volt and the potential difference across the resistor B is 1 volt. Right? So then we'll try to take a relationship here. So by looking at the values you have in the circuit, you can understand that the voltage or the EMF of the cell is equal to the sum of the voltages gained by each resistor. So that means like this. So the EMF of the cell is 1.5 volt. No, so the voltages gained by each resistor. That means the resistor A gains a voltage of 0.5 volt and the resistor B gains a voltage of 1 volt. So here we can get a conclusion like this. That means EMF of the cell is equal to the voltage gained by A plus voltage gained by B. Compare the ratios between the resistances and ratios between voltages. First I'll take the ratio of resistances here. So then here the resistors used in this circuit are 100 ohm and 200 ohm. No? So the ratio between resistances is 100 is to 200, or the smallest ratio is 1 is to 2. Then we shall consider the ratio of voltages. Yeah. So then in this case 100 ohm resistor has a voltage of 0.5 volt and 200 ohm resistor has a voltage of 1 volt. So there also the smallest ratio is 1 is to 2. So you can understand that in a series connection, ratio between resistances is equal to the ratio between voltages. I think you understood that concept. And this covers the fundamentals of how series circuits work. By now, you should be comfortable calculating total resistance, current, and voltage drops across the components connected in a single path. In our next video, we are going to put this knowledge to the test. We will be walking through some past paper questions to show you exactly how these concepts appear in exam and how to tackle them with confidence. Thank you for watching, and I'll see you in the next one.
If this video made that light bulb go off in your head, do me a quick favor. Smash that like button and subscribe to the Newton Nuts channel. It really helps me keep creating these free lessons for you. Now, if you want to completely ace your upcoming exams and need a little extra support, I've got something special for you. Head over to www.newtonnuts.com right now. To make sure we are a perfect fit for your learning style, every single student gets a 30-minute, one-to-one free trial class before we officially begin. No strings attached, just 30 minutes of dedicated, personal physics help to kickstart your progress. Thanks for tuning in today. If you enjoyed this lesson, stay tuned. I'll see you in the next video with more exciting topics.